Hello, everybody. Good evening, as we say down here in Houston. My name is Devon Adams, along with my partner Shannon Jones. We're going to be discussing a new topic, continuous probability. Very easy concept today. Just an activity today, no homework. Going to be going over what continuous probability is and how to use it in your everyday life, including statistics. Very, very important. I also want to give a special shout out to the breast cancer awareness victims. Um, we all know that you guys fought very hard uh, through this tough war, and I just want to salute to all the breast cancer survivors and just wish for continued success. But other than that, let's go ahead and get started. So first of all, we want to know, what is continuous probability? Continuous probability is a distribution that has a specific range of two variables. Like, for example, if you want to join a firefighters association, you had to weigh in between 150 and 200 in order to join the group. If I'm 205, can I join? No. I have to fall within that specific range of what they want me. If I'm 183, then I'm good. I can join to be a fighter. So as long as the variable falls between those numbers, like 209 and the other number that I stated before, then the distribution is a continuous variable. And like some other variables are, the time from school to get to your house. Roughly, it just takes me like 5 minutes because I'm not even that far away from campus. The length of each song on the latest Coldplay album. I haven't heard them for a while. In the age of years of 9,500 employees at VIA Metro Transit. If you don't know what that is, that was my that was the transit back in San Antonio. Um, it's a pretty good transit system, but I'm pretty sure they probably have less than that. But these are just examples of continuous probability and what they really are. So in the next example, we're going to be using the real estate data, as always, given to us by my favorite statistics teacher. So we're going to be using the example from the real estate data. So for this example, we're going to be using one variable because I thought it would be convenient because none of the very other variables didn't make sense for continuous data. I thought the size would be, but in reality, the prices of the house particularly vary in this case. So we're going to be using the price of the houses. We're going to use township 4 from this variable. So basically, a house's value changes over time. Like, say if you buy a $200,000 house and you plan on selling it, it's not going to cost $200,000 in the future. So like it says here, like if I bought a house for 150 grand and that's a depreciation of 3 years, it's going to cost 100 for it in the future. So it's really not going to cost that much. So this is going to be the table that we're going to be using, like I said, from the Township 4 data, from the real estate data. As you can see, the prices of the houses are on the left-hand side. As you see, the first price on there is the 125, 125 grand in this case. And as you look towards the bottom, you can see 345.3. That's the highest price. That's the data set that we see here. So in the next spot here, we have we graphed all the data so we can make sure what we're looking at is accurate. I do apologize. The my mouse keyboard keeps on messing up, so it took me a little bit of time to draw out the scale of the graph. So when we're dealing with continuous data, we're trying to find like the middle portion, like the range that we're dealing with here. So what we just went through, there is an equation, or a formula in this case, rather, when we're dealing with continuous distribution. And that equation is P equals 1, parentheses, B minus A, the probability of event B, minus the probability outcome of event A. And again, times 1 out of B minus A event. So let's say the probability of the outcome for the price of house R, and the data is between the data that we just described when we were introducing our table, which is 125 and 345, 300. We want to find the probability of the value if R. So we set up the equation which is P equals 1 over 345,000 minus 125,000, event A and event B. So we get R as 1 over 2200, 300. So that's the possibility outcome of finding the house at that particular price. Alright guys, well that's going to do it for continuous probability distribution. There won't be no homework tonight. This will be the only activity that I'll be doing for the day, this evening rather. So thank you guys again for watching. So yeah, I'll see you in the next video. Thanks for watching.